Hello everyone, this is Hamza Noor and today I'm here with another video, A-Levels Maths S1, May June 2020, paper 5-3, question number 7, and the topic is permutations and combinations. Today is the big day, 14th of October 2020, and my best wishes to all of you. And students have worked so much hard throughout the year, all of the institutions, all of the teachers. Good luck to all of them. And now it's the time to prove what you've got. Alright, so let's start with question number 7. Find the number of different possible arrangements of the 9 letters in the word celestial. Okay, 9 letters means 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, but make sure just to check which letters are repeating. 2 L's and 2 E's. So 9 factorial divided by 2 factorial times 2 factorial. So the answer is, because two e's are repeating and two l's are repeating. 9 factorial divided by 2 factorial times 2 factorial. This is 90720 ways. Part B is saying that find the number of different arrangements of the 9 letters in the word celestial, in which the first letter is C, the fifth letter is T, and the last letter is E. Altogether you have 9 spaces: 1, 2, 3, 4, 5, 6, 7, 8, and 9. But you have to deal with the restrictions first. So C is in the beginning, E is at the end, and T is in the fifth position. 1, 2, 3, 4, 5, fifth. Here it is. These are the restrictions. Okay? So you cannot move them away. You cannot adjust them further. These are already over there. So how many spaces are you left to fill with now? 1, 2, 3, 4, 5, and 6. 6 factorial ways. Two E's won't be repeating themselves because one E is already placed. So two L's are repeating themselves because L is not in these positions. Okay. So 6 factorial divided by 2 factorial. How much is it? How much is it? 360 ways. Easy. Let's come on to the next part. Part C is saying that find the probability that a randomly chosen arrangement of the 9 letters in the word celestial does not have the two E's together. Okay, so you don't want two E's next to each other, right? What if these two E's are next to each other? You have 9 spaces altogether: 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, two E's are next to each other, so you'll consider them as one single block. And how many spaces are there? 1, 2, 3, 4, 5, 6, 7, and then you consider this as one single block. 8 factorial. 8 factorial. All right, two e's are there, multiply by 2 factorial. But wait, two e's are also repeating themselves. All right, and two l's are repeating themselves. Okay, so 2 factorial and 2 factorial are cancelled out, and here you have 8 factorial divided by 2 factorial. 20160. These are the ways in which two e's are together, but you don't want them to be together, right? So what I'm going to do is subtract these possible arrangements from the total number of arrangements which were without any restrictions. Okay, always remember that in such cases you need to check back in the answer of part A, the requirement of part A, if you have, I mean, whether or not you have calculated the total possible arrangements without any restrictions. I mean, in some cases, in some questions, it has been seen that in the previous part there are some restrictions, so it is not always so much simple to use the previous answer, the previous part answer. So you need to check if the part A has given you the answer without any restrictions. So 90720 were the ways, were the possible arrangements in which the 9 letters can arrange themselves without any restrictions. Okay, so what I'm going to do is 90720 is the total possible arrangements. I'm going to take away 20160 from this. So I'm left with how many ways? 70560 ways. But wait, read the requirement again. The question is asking about the probability. So 70560 divided by total possible arrangements 90720. So 70560 divided by 90720. This is 7 over 9. 7 over 9 is our answer, or 0.778. And other alternative approach is to use a separating model. I have discussed that separating model in my previous videos as well. So whichever method you are easily equipped with, and you can get and that particular method can get into your head easily, so it is most recommended to do so. Anyways, full flash is straight away 4 marks for this working, so I'm not gonna repeat that that particular method over here again. You can try it on your own self after watching the two previous videos. In fact, yeah, two previous videos: June 2020 paper 5.1 and June 2020 paper 5.2. Alright, let's come on to the next part. Part D is saying that 5 letters are selected at random from the 9 letters in the word celestial. Find the number of different selections. Now here you have to deal with the combinations. Find the number of different selections if the 5 letters include at least one E and at most one L. Let's just figure out how many E's do we have. We have 2 E's and we have 2 L's, right? So we need the number of different selection if the 5 letters, I mean, because 5 letters are selected at random from the 9 letters, you have 5 spaces to fill with. 1 2 3 4 5. All right, at least one E. You need at least one E. Okay, so let's consider the first case in which we have only one E, because I'm going to make number of possible selections over here. Okay, number of different combinations, possibilities of combinations, right? So at most one E means sorry, at least one E, you have at least one E, and at most one L. At most one L. Maximum you have two L's, so you need at most one L. So now in this way, in this possibility, E will not repeat itself. E is not going to repeat itself, and L is not going to repeat itself. How many E's and L's do we have? We have two E's and two L's. Altogether we have 4 letters. Just take away these 4 letters, which are two E's and two L's, from your total number of possible letters. Okay, so 9 minus 4 is giving you 5. Now, out of 5 letters, you have to select how many? How many spaces are you seeing here which are empty? 3 spaces. So 5, choose 3. 5C3. This is my one possible combination. The other possible combination is that I have two E's. I have two E's. And at most, I should have one L. So how many letters are you left to select from? Obviously 5. Okay, obviously 5, because in the same way, I mean, E is not going to repeat itself because there aren't any E's further, and L is not going to repeat itself in this case as well. So you are taking away these 4 letters from 9. So 5, choose 2, because you have 2 spaces to fill with. All right, so this is 5C2. All right, what's going to happen next? Another possible combination is that where you have 5 different letters, I mean 5 spaces to fill with. Okay, and at least one E. All right, and at most one L. I mean, it is also possible that you have two E's and you don't have any else. You don't have any else, because at most one L means maximum you have one L. I mean, two L's are not possible in this scenario. So I'm just going to assume that I have now basically I have 3 spaces to fill with. But again, I don't want any other E because I don't have any, and I don't want any else further in this possible combination. So I have 5 letters to choose from, but I have 3 spaces left over here. So 5C3. All right. And what else? What else? Other possibilities that I have one E. I have one E over here, and I don't have any of the L's. I mean, I need at most one L, right? I have only two L's. I need at most one L. So zero L's. So zero L along with one E only. because you need at least one E. You can't have a possibility that there is no E. All right. So, I mean, sometimes it can be a little complicated to get this whole scenario into your head. But as much as you have done your practice, I hope that you would be able to tackle these sort of questions. All right. So I have five other letters to choose from, but I have four possible spaces to fill with. Five, choose four. All right. As simple as that. So 5C3 plus 5C2. I mean, what's 5C3? First, take it out. This is 10. 5C2 is 10. All right. 5C3 is 10. And 5C4 is 5. So total you have, sorry, 5. So total you have 35 ways. All right. Best of luck to all of you for exam, and my sincere wishes to all of you. And I'm sure each and everyone is gonna rock the paper. Until next time.